Hello, mathematicians. Today we're going to talk about identifying angles. So this is going to be part of our new unit. I'm going to show you a really quick brain pop video to kind of give you a general overview. We'll talk about our learning targets, and then we'll go over some important vocabulary. I'm going to play the video, and if the sound doesn't work, make sure to follow along with the caption.
Six o'clock? Well, it's 2 o'clock. You can't just change the time because you like the way the hands look. Dear Tim and Moby, how do you measure angles? From Pablo. An angle is made up of two rays that share the same endpoint. This common endpoint is called the vertex. Angles are often named by the label of their vertex. So we could call this angle angle B. If the other angles in the diagram share the same vertex, we'd also use the labels of the rays. So now this is angle ABC. The corners of your house form angles, so do the hands on a clock. Oh, well, I borrowed Dad's protractor, which I'm going to use to measure the angles in our clock. Another way to think of an angle is just as a section of a circle. A protractor represents all 360 degrees in a circle, so we can use it to measure whatever angle we're interested in. At 2 o'clock, we're looking at an acute angle. Acute angles are less than 90 degrees. 3 o'clock forms a right angle. Right angles are exactly 90 degrees. Clock hands at 4 o'clock show us an obtuse angle. Obtuse angles are greater than 90 degrees. With the hands at 6 o'clock, we're dealing with a straight angle that measures 180 degrees. Right, that's also just a line. That's a pair of angles. Two angles that add up to 180 degrees are called supplementary angles. Two angles that add up to 90 degrees are called complementary angles. So that's about it for measuring angles. We kind of wrecked that clock.
Now that you've gotten to see a brief overview of what we're going to talk about, I'm going to go through some vocabulary with you. First, our learning target says we're going to learn about acute, right, and obtuse angles. Our performance of understanding, we will use the paper test to identify angles within a polygon as an acute, right, or obtuse angle. We can determine whether an angle is acute, right, or obtuse. Here is our vocabulary. So a right angle is another term for a quarter turn. So just like they described with the clock, a right angle is 1/4 of that clock, or the circle. So because a right angle is a special angle, we often mark the inside of an angle in a special way. We draw a square because a right angle forms a corner of a square. So this is where our paper test comes into play. How many right angles are in this rectangle? How many of these angles are right angles? How can you test your prediction to make sure that it's a right angle? Pause the video here, grab a piece of paper, and see how many right angles you could make. What about with this polygon? How many right angles do you think you could make? Are they all right angles? If they're not, what kind of angles do you think they are? Let's continue going with our vocabulary and we'll come back to this. Here I have a straight angle. This is a half turn. What do you think the measure of this angle is? Why do you think it's that measure? They mentioned it in the video, so maybe you can remember. A half turn is 180 degrees. we often compare other angles to these angles. Right angles and straight angles are usually ones that are benchmark angles. We use these to gauge what type of angles we're working with. So an acute angle, like mentioned in the video, is less than a quarter turn. So it's less than 90 degrees. How many degrees can an acute angle measure? What do you think? If a right angle is 90 degrees, what's the smallest or largest that you think an acute angle can be? On this shape, I want you to point to which ones you think would be acute angles. The R's are labeled by right angles. So we'll come back to the shape again. There's only one right angle in this polygon. Now we're going to talk about an obtuse angle. An obtuse is more than a quarter turn and less than a half turn. So that means that an obtuse angle is larger than a right angle, but smaller than a straight angle. So what does this tell you about the measure? If a right angle is 90 degrees and a straight angle is 180 degrees, how much do you think an obtuse angle is measured at? Next, I'm going to have you look at this polygon again. So we have one right angle, one acute angle. What do you think that means for the rest of these angles in this shape? Maybe that means that they're going to be obtuse. How do you know? So, can you have a triangle with one obtuse angle and one right angle? Can you have a triangle with two obtuse angles or two right angles? We're going to find this out during your small group lesson. Make sure that you go back and look at the vocabulary words. Write those down in your math journal. If you need any help or you have any questions about the words that we've gone over, make sure to write them down and come to small group ready to ask. Good luck.